welcome back to my channel. Thank you so much if you're coming back, and if this is your first time, thank you. I really appreciate you. So today I'm gonna be explaining as well as demonstrating Kubernetes clusters, nodes, pods, and containers. And in my last class I was able to show you how you can create or deploy an application in a Kubernetes cluster. I'm gonna be leaving the link in the description below if you are yet to see the video. Alright, so today I'm actually ready. If you are ready, let's get started. But before I go ahead, please click on the subscription button and subscribe to the channel, and as well click on notification. That way you get notified each time I publish a new video. Kubernetes node, also known as Minium, is a physical or virtual machine within a Kubernetes cluster. So Kubernetes helps to run your workload by placing containers into pod to then run it in a node. If you look at my the image I have here, you have a cluster, and then inside the cluster you have a node. All right, so the node is actually the physical or virtual machine that helps to run your workload. So in the node, after having the node, you then have a pod and containers, which will explain in a moment. So just note that in a cluster, in your Kubernetes cluster, a node is just physical or a virtual machine that helps to run your workload. So nodes are actually the integral part of a Kubernetes cluster, and it helps to provide the necessary compute resources for running an application. So I'm going to show you in my terminal or in my cluster what a node looks like. Over here in my Kubernetes cluster, so first of all, I'm using Kubeadm. I set up my cluster using Kubeadm 2, and I actually have the video where I set it up. I'm gonna be leaving it in the description below, so that if you want to set up your own cluster, you can go ahead and set up. So over here I want to run kubecontrol command to show you the node that I have in this cluster. So kubecontrol get nodes. So this is on-premise setup where I have one master and one worker node. So to also get more information about this node, I'm gonna type -o white, press enter. So this will display more information about our nodes. Okay, so you see the name, the status, the roles, age, version, internal IP. It's on Linux because that is what I use. That is the EC2 instance I use to set up this cluster. All right. What if you're using a particular node and the application running in the node fails? What will you do? So obviously your application will go down. All right, so that is why it is encouraged or recommended to have more than one node for high availability or fault tolerance. All right, so as you saw in my terminal, I have just one master and one worker node. By the way, I'm gonna be explaining this master and worker. Just note that I don't really have in my cluster, there is really nothing like fault tolerant, but because that is not really a production Kubernetes cluster, okay, it's just there for testing purposes, and also I also use it for my tutorials. So I'm not really paying attention to fault tolerance. But if this is production, you obviously need to have more than one master node and multiple nodes, okay, for fault tolerance. So now let's talk about various type of nodes to run your applications or workload, and you have different options. The first one is bare metal servers. What is this all about? So you can actually have a dedicated physical servers in your data center or your infrastructure, which you can use as your Kubernetes nodes. Okay, so this one will offer you direct access to hardware resources and potentially higher performance. So some organizations use bare metal, all right, fine, and there is a potential of having a higher performance when you use bare metal. And we have managed Kubernetes services. So in public cloud, in different cloud services we have, you can actually use their managed Kubernetes service there to run, or to to have your own nodes. So you can opt for managed Kubernetes service in AWS, Azure, GCP, and other cloud providers that offer the service. Okay, so this service abstracts the underlying infrastructure, allowing you to focus on deploying and managing your applications. And then we have virtual machines. So you can actually you can have that flexibility and isolation for running your Kubernetes nodes. Okay, give you the flexibility you need, and you can actually run this on various virtualization platform. Okay, so these are different options you can actually use to set up your nodes on your Kubernetes cluster. Now let's talk about this Kubernetes cluster. What is it all about? A Kubernetes cluster is just a group of nodes that work together to run containerized applications and manage their associated resources. So a cluster contain multiple nodes. It can be two nodes, it can be three nodes, and all that. So it's just like a cluster of nodes. Is a group of nodes that work together to run your containerized application. So this set of nodes is basically the fundamental building block of a Kubernetes environment. So when you have multiple nodes within your cluster, if one node fails, you have your application still running because there is fault tolerance. Okay, so it is recommended to have multiple nodes running your workload. So in a cluster, we actually have two main types of nodes. The first one is the control plane, also known as master node. Okay, so this node helps to host the control plane components, which are responsible for managing and coordinating the cluster. And we have different components in this control plane node, such as API server, etcd. etcd is a distributed key value store for cluster data. Another component is the scheduler, and we also have the controller manager. All these components actually help to handle tasks such as accepting and processing API requests, scheduling containers onto nodes, and monitoring the cluster health. We have another type of node called worker node. So this worker node runs the actual workload. It runs the actual workload, which is the application that will be running in your cluster. Okay, so they execute containers, manage their life cycles, and handle networking and storage operation. So each worker node you have in your Kubernetes cluster actually have a container runtime such as Docker, and also in the same node you have a kubelet, because a kubelet need to be present in all the worker nodes. Okay, we also have a kubeproxy in your worker node. For this one is for networking and other necessary components. All right, so please note that in a worker node you have the kubelet, you have the kubeproxy, and as well as the container runtime. There are actually different ways to set up Kubernetes clusters. So depending on your use case or specific requirements, okay, so there are different ways you can set up your Kubernetes cluster, and let's see some of the approaches. First of all, we have self-managed cluster. What is this all about? So in this self-managed cluster, you can manually install and configure the Kubernetes cluster on your infrastructure. So this setup include, it will require you to set up your Kubernetes control plane component, which is the API server, the etcd, the scheduler, the controller manager, and you also set up the container runtime on your own. Example is Docker, like I've mentioned. So you're actually responsible, like you are responsible for managing the clusters infrastructure, such as the upgrading, the fault tolerance, the scaling, and all. So this is self-managed, meaning you take care of overall management of your cluster. And we have managed Kubernetes services. Kubernetes services are actually offered by cloud providers such as AWS, GCP, Azure, and in AWS it is called Elastic Kubernetes Service. For Google it is called EKE, and Azure it is AKS. Okay, so the cloud providers actually help you to manage the underlying infrastructure and manage the control plane of your Kubernetes cluster, providing the features such as automatic scaling, monitoring, logging, and also integration features with other cloud services. This is for the Kubernetes cluster itself. While you focus on your application, the monitoring of your application and some other stuff. All right, so this is managed Kubernetes services. The third one we have here is on-premise clusters. For the setting up, it will involve you to set up the Kubernetes infrastructure in your own data center. Okay, it will require you to provision physical or virtual machines. You will configure the networking, you will install the necessary software components like Kubeadm, Kubespray, Rancher, and many of them. Okay, so for instance, for the link I promised to drop in my description, in the description below, it is a Kubeadm. We use a Kubeadm to set up our Kubernetes cluster. Okay, that is on-prem clusters. Okay, so these are actually the common approaches through which you can set up your Kubernetes cluster. Now let's talk about containers. What are containers? Containers are running instances of your image. They are actually isolated and have their own environment and set of processes. When I produce, or when I publish a video on Docker files, I showed you guys how to create your own custom image using Docker, as well as run your containers. So when you spin up your containers are actually the running instance of your images. I'm gonna be dropping the link where I explain Docker containers, images, and how to create your Docker file. So containers are lightweight. They are isolated packages that help to bundle your application with their dependencies, making it to be portable and allowing it to run consistently across different environments. So with containers, we don't have issues such as it is working in your machine and is not working in mine. It is actually very consistent across different environments. So containers are actually efficient, starting quickly, and it can consume fewer resources compared to the traditional virtual machine that you have. Containers support easy scalability, and a key component of DevOps practices, enabling automated deployment and CI/CD. So Docker is actually a popular containerization technology that helps to simplify the creation and management of containers. We have other other containerization technology you can actually use to achieve containerization, okay, or to have your containers. But Docker is a very popular containerization technology. Now let's talk about pod in Kubernetes. So in Kubernetes, our primary goal is to deploy application, right? So our primary goal is to deploy applications. Okay, but we are not just deploying that application as just a normal application. We are deploying it as containers. So it is actually the pod that will be running your container. So you don't just put containers to be running inside a node. Okay, so it is actually encapsulated into a pod. So remember, you have your cluster, and cluster will contain nodes. Okay, and so the nodes will contain a pod, and the pod will contain your application, which is actually the container. So a pod is the smallest object you can create in a Kubernetes cluster. Please note that. So let's take a look at the scenario I have here. Okay, so assuming we have a cluster with just one node, and the node contains a single instance of our application running in a Docker container, and it is encapsulated within a pod. So what happens if the users accessing our application increases and we need to scale it? What happens? So if you need to scale it so that it can meet with the current demand you have, because for you to have more users trying to access your application will require you to scale it. So what will you do? So what you basically need to do is to spin up another pod, because okay, so this is my pod here, and so let's assume we have users trying to access this pod over here. You actually need to scale it. Okay, so that you need to scale your application so that it can actually serve more users. But you don't just scale it, you don't start scaling your containers, and so that I have two containers running in a pod. As you can see, I have to mark it bad here. All right, so you need to spin up another pod so that you can have two pod. For instance, so you don't just spin up a container to be running in the same pod. Okay, you don't run two container. It is not actually recommended that you run two containers inside the same pod. So what you need to do to scale that application is to deploy another pod. So this is not actually recommended, but there is a case where we have multi containers. Okay, there is a scenario where we actually need to run multi containers, like having more than one container inside a pod, and that is actually when probably you need a helper container, maybe a web application that actually require messaging services, so you give it a helper container to actually kind of help it out. Let me use that word. Okay, so that is the scenario where you need to have multi-container. But if you don't really have or want, or if your container doesn't really require a helper container, then it is recommended you run a container per pod. So let's now go ahead and create an Nginx pod in our Kubernetes cluster. So this is I'm in my Kubernetes cluster right now, and so I want to run a command to check if I have an existing pod. All right, so the command is kubectl get pods. So with this command, you can view the available pod you have in your cluster, and actually have one existing pod already, which is fine. So we can go ahead and create our pod. So this pod we want to create, there are two primary ways to create a pod. We can use imperative method or declarative method. So declarative is when you use a YAML file or JSON file to create your pod. So this is Kubernetes documentation. How did I get here? I simply typed Kubernetes and I clicked on once. Okay, so let me show you. So just type Kubernetes here, click on Kubernetes, and then click on documentation. So let me close this out. So over here, just type pod, press enter. This is pod over here, so I'll go ahead and click on pod. So here let's go ahead and copy the manifest file. So this is a manifest file, this is a YAML file, and it is a YAML file we can use to create a Kubernetes resource called pods. So you can actually read more about pods over here, but I'm interested in getting this YAML file, so I'll just copy this. So here, how do I create how do I create this pod? I'll have to create a file first. All right, so I'm gonna use vim, and let me call this file pod YAML, and I'm gonna press enter. So here I'll paste what I just copied. So this is called a manifest file. This is actually a representation of Kubernetes pod resource. So let's break it down. So first of all, we have API server here. This API server actually specifies the API version of Kubernetes that the manifest is using. In this case, it is v1. Okay, it's v1 version, so it is the core Kubernetes API version. The second line, we have kind. And what is kind in this manifest file? Kind, specifies the type of Kubernetes resource being defined. So over here, it is a pod, because it's actually a pod that we want to create. So that is why we have the kind called pod. Okay, so kind is the pod is our kind in this manifest. All right, I know, remember, pod is the smallest deployable unit in Kubernetes. Over here we have metadata. Metadata basically contains the information for your pod, and under metadata we have name. So this name specifies the name of our pod. Okay, and the name of our pod is Nginx. Okay, so you can name this pod whatever you want, but I choose to leave it as Nginx. So here we have the spec. So this spec describes the desired states of your pod. So here for the containers, so the containers, these containers contains an array of containers running within your pod. So we just have one container here, and the name of our container is Nginx. Okay, the image is Nginx 1.14.2. so you can actually use any other version you prefer. This can be gotten from Docker Hub. So as for the ports here, the port specifies an array of ports that the container exposes. So this container ports, defines the container. It defines that our container will listen on port 80. Okay, so basically when we apply this manifest file, it will create a pod for us named Nginx. Okay, the name of our pod will be Nginx, running on a single container, and it will be using this image, okay, with this port expose on port 80. All right, so now that I have explained this manifest file, let's go ahead and save it. And right now we have to then apply this manifest. And how do we apply? So we use this command kubectl or kubecontrol apply -f, and what is the name of our file? It is pod.yml. I'm gonna press enter, and our pod has been created. So let's confirm it. Kubecontrol get pod, press enter. As you can see, I now have my Nginx pod running. So to get more details about this pod, I'm gonna append -o wide here. Press enter. So with this you can get more details about your pod. So here you can see 1/1 is ready, meaning I have one container inside my pod and is ready. It is running. Okay, there's no restart yet. The age is 20 seconds ago. This is the IP please note all pods have an IP address, and as you can see, the worker node is running on is a worker node. So the pods, once you deploy your pod, it will definitely run on a worker node. Okay, so that is it about this pod. So we can actually describe this pod to get more details about this pod. Okay, all the the components, the image, and all that. So to get more detail about this pod, let's use kubectl describe pod, and then I'm gonna type the name of this pod, which is Nginx. I'll press enter. So over here we can see we have the name, we have the namespace, the priority, the labels, and just all the information about this pod that you actually need to know. This is the IP over here, and the container in the content. So this container section here actually contains the information about the container running in our pod. Okay, so the image we use in creating our container is this Nginx image here. Okay, so Kubernetes use this image to launch the container which is running inside our pod. This is the image ID, and this is the port we expose it to, and the status or the state shows that it is running. If you come over here, you can actually see under event, you can actually see how this container was launched, or the scheduler, which is actually responsible for scheduling your pod onto the node. So it successfully assigned the default Nginx to a worker node. All right, as I showed you earlier. So this container image, this is the Nginx image here. Okay, it's actually present on my machine, so it didn't bother pulling down a new Nginx image. So what happens is that if you've already used Nginx image of this type or this version to deploy your pod or your container, it actually doesn't go to pull down that image again when you use the same image to create your container. All right, so that is what happens here. I've used this image before on this node. That is why it didn't bother to pull down a new image for me. So with the existing image, because I have it already on this node, my machine, right, it created a container. It created container Nginx, and it started the container. So Kubernetes is actually responsible for pulling down the image if it's not in existence in your machine. After it pulls it down, it will create a container using that image. Okay, and the same kubelet running on your node also will start the container for you. So this is it about pod. I hope you enjoyed this. So that is it about this tutorial. I was able to explain what a Kubernetes cluster is, what a node is, what pods and containers are. All right, and I was also able to show you the nodes I have in my cluster. I showed you what pod looks like, how to use a manifest file to create your pod, and we successfully deployed a pod. And I also explained how the image was used to create our container, which is actually running in our pod. Alright, thank you so much for sticking to the end of this video. Please, if you like this video, give me a thumbs up by liking it. Subscribe if you're yet to subscribe. Click on notification bell to get notified each time I publish a new video, because I have a lot to share with you guys. Kindly comment on this video, share it within your network. Thank you so much. I appreciate you. I'm gonna see you in my next video. Thank you and bye.